Hello friends. So this problem is about a buzzer falling on a rubber cord. So problem says a smooth rubber cord of length L with force constant K is suspended from point O of ceiling, and at its other end a light support B is fixed. A small buzzer A of mass M starts falling from point O and hits the support A. You have to neglect the mass of cord and find the maximum elongation in the cord. So what are the things that is given? So we have a rubber cord. So this is a cord and made up of rubber. Length of this cord is given. This is the natural length. This is L. And then force constant for this rubber cord is also given. So we have been given this force constant K and natural length L of this rubber cord. This rubber cord is suspended through ceiling, and this is point of suspension is O. And on one end we have a very light object. This is B. So this says light support B. So this is a light support B. And then we have a sleeve. So here I have a sleeve, and the sleeve is A. Mass of this sleeve is not given in this problem, but for, let's say, it should be given. Let us say mass of this sleeve is M. So M is the mass of sleeve. Basically this mass is given. You see, mass M starts falling. So mass of sleeve is given. Now, so these are the things that is given in the problem. And what we have to find? We have to find maximum elongation in the cord. So when this sleeve comes at point B, we have to find maximum elongation. So what will happen? So if I make the same thing, so this will be, so I can move it here, and then so what will happen when this sleeve is basically fallen here? So in the second situation, this sleeve will come here. So finally this sleeve will come here. Now in the process of motion of this sleeve, what are the things that will happen? So you have a rubber cord. So this cord is made up of rubber. So this rubber cord will elongate, because once this sleeve is going to collide with this B mass, then it will try to elongate the rubber cord. So rubber cord will elongate. So you will have elongation. So there will be elongation in rubber cord. Rubber cord. Basically this rubber cord will behave like a spring. That's why a spring constant or force constant K is given. So this rubber cord is more like a spring. Let us say elongation in this spring or in this rubber cord is X. So what will be the total length of this rubber cord after this elongation? So this length will be, initial length was L. So now this length will be L plus X. So let us say initially this sleeve was here, and then this starts falling, and then this sleeve basically fall through a distance of L plus X. Now what will be the velocity when this collides here? What will be the velocity of sleeve as well as this light mass B? Basically this is a maximum elongation. This means velocity should be 0. Otherwise, if there is a velocity, then it will further extend. Then in that case, that will not be a maximum elongation. Since X is maximum, so X is maximum elongation. So this means I can say velocity of mass is equals to 0. Now what we have to find? We have to find maximum elongation, X value. Now how will you solve this problem? you see in this case there is no loss of energy. So you apply energy conservation and then you can solve this problem. So you apply energy conservation and solve this problem. So let us pause this video and solve this problem. So we can solve this using energy conservation. So what you have, initial velocity is 0 and final velocity is also 0. So there is no kinetic energy change. So we can say in this case, loss in potential energy of the slave. So whatever there is a loss in potential energy of slave, that has basically been stored in the rubber. So we can say loss in potential energy of slave is equals to gain in potential energy in rubber cord. So rubber cord. So what is loss in potential energy? So mass m has fallen through a distance of L plus x. So this loss is mg L plus x. And what is gain in potential energy in the rubber cord? That is half kx square. So now from here you can solve for x. So you can write 2mgl plus 2mgx is equals to kx square. So from here I can say kx square minus 2mgx plus 2mgl is equals to 0. So x is equals to minus b, that is plus 2mg plus minus b square, that is 4m square g square, b square minus 4ac, so 4 times k times 2mgl and divided by 2a, so 2k. So this is the x value we'll have. You can further simplify, you can write x is equals to 2mg and this divided by 2k, so 2 basically cancels out. So mg by k plus minus and 4 we can cancel and we can take k inside. So you will have mg m square g square by k square and 4 already cancelled out. So you will have 2mgl and 1k will cancel and this divided by k. Basically there is a plus, so this will be, so this is not plus, this is minus. So everywhere I have to change this. So this is minus, so this will becomes plus, this will become plus. So now x is equals to mg by k, and if you take mg by k common, then you will have a square root of 1 plus, this term will be 2lk divided by mg. So this will be the final elongation in the rubber cord. Now there are two possible values. One value will be negative because this term is greater than mg by k. Because this term that is inside this square root is greater than 1. So this term is greater than mg by k. So negative sign has no meaning because in that case elongation will be negative. So we have to consider only the positive value. So x will be mg by k plus mg by k a square root 1 plus 2lk by mg. So this will be the final elongation. So now question for you. What are the assumptions that we have made in this problem? So we have made some invisible assumptions. For example, I have made assumption that this slave, when this collides, there is no loss in energy. I have also made an assumption that this rubber and this slave is basically in contact, but there is no friction. So these are the assumptions that I have made. There are other assumptions that I also made, like this rubber cord is straight always, it will not move either left or right, something like that. this rubber cord is straight, so there is no slack in the rubber cord. So these are the assumptions that I have made. You can think yourself what other assumption that has been made in this problem and discuss in the comment box. So I hope you enjoyed this video, and if you enjoy, please share with your friends, and I will see you in the next video. Thank you.